YouTube channel. So today and now we are going to discuss and finish up this topic, the crystalline and solid state part 6. So in this part 6 we are going to discuss about the ionic crystal structure of the cesium chloride. For the cesium chloride, okay, where the size of the cation and also the cesium cation and also the size of the chloride ions almost have no different, okay, alright. So what happened here, the radius ratio of the cation and also anion can be represented as between 0.732 until 1, okay. Alright, so this is the cesium chloride structure, okay, the cesium chloride structure. The blue one is the chloride, while for the red one is the cesium. Okay, so because of the sizes of cations and also anions are almost similar, okay, here the layers of anions in white, okay, and the cations in black, okay, are arranged in squares, okay, right, and will be stacked as here in the diagram, okay. So this is the anions and then stacked in squares, okay, with the cations and then followed by the anions. And what we are having here, okay, what we have here, the cesium chloride structure, okay, based on the BCC, body centered cubic, okay, right. So the coordination number of the cesium chloride is 8, okay, where we have 8 anions occupying the corner of the cube, okay. So the white one here is the anion, so we have 1 over 8 times 8, so it will give us 1 ion, 4 or 1 anion, and then plus, okay, where we have only 1 cation, right, this is 1 anion, okay. So 1 plus 1, we will be having 2 ions, okay, for the cesium chloride structure. Okay, so that's all for the cesium chloride. So this is the summary of part 4, 5 and also 6, okay, where we have in part 4 we have the zinc blende, and then we have rock salt in part 5, and last but not least in this last part, part 6, cesium chloride, okay. So these are the structures of the lattice type, okay, zinc blende, rock salt and also cesium chloride. And last but not least, the density calculation, okay. So this is where we have or how to calculate the density of ionic solid with a sodium chloride structure, okay, where the H length of the unit cell must be found, okay. The H length is the A, okay, alright. So since the cation and also its nearest neighbor anions, okay, by definition in contact, therefore the cell H length for sodium chloride is given as, this is the formula, A equals to the 2R of the cation, R is the radius, okay, plus 2R of an anion, okay. So I have a question here, okay. The H length of the sodium chloride cell unit cell is 564 picometer. What is the density of sodium chloride in gram per centimeter cubic? Okay, so this is mass over volume, right? So the volume per unit cell is A to the power of 3, okay, alright. So here we are given with the value in term of picometer, so you need to convert the picometer to the centimeter cube, okay, alright. So here, okay, this is the volume here, 564 times 10 to the power of negative 10 centimeter. Okay, and then you need to determine the mass per unit cell, okay, of the sodium chloride. Okay, so here we have 4 times 23 plus 35.5, okay, the sodium and also the chlorine. Okay, so we will we get, okay, 234 AMU. And then in order to determine the density is mass over volume. Sorry, it is supposed to be volume here. Volume supposed to be here, right? And then this should be here. Alright, so the mass, okay, divide by the atoms, okay, the Avogadro number of atoms 6.02 times 10 to the power of 23 divide by the volume, okay, must be in centimeter. Okay, so you need to convert the picometer to the centimeter because the question asks you gram per centimeter cubic. So the answer is 2.17 gram per centimeter cubic. Right, and then so this is the practice 3. Please do this and we will discuss later in our virtual class. And that's all for today, and that's all for the crystalline and solid state. I hope you guys enjoy the video, and please try this practice. Okay, so that's all for today. Thank you everyone. Bye.